Hello and welcome to this week's live stream. It is Sunday afternoon at 2 p.m. Today we're going to be looking at how to solve linear equations for GCSE Maths. We've had two live streams this week. We've had an English one on Thursday and today we are looking at Maths. So welcome to everybody on Patreon. Thank you so much for joining me. Do make sure to download the worksheet that we'll be working through later underneath this stream. This will just put together all of the knowledge that we're going to be looking at today. So we're going to go over the theory and then put that theory to the test with that worksheet. So everybody on YouTube, thank you very much for joining me. Please remember to like, comment and subscribe, and consider joining the Patreon in the description below, where you will be able to see this full lesson. So you'll see about half of the lesson today on YouTube, where I'll be going over the fundamentals of how to solve linear equations. And then, as I said, we'll be doing some extra practice with a worksheet for those on Patreon. So we'll be able to put our knowledge to the test and check that we have understood the lesson. Okay, so without further ado, I'm going to start making some notes now. So everybody grab your notebooks, grab your pens, and we're going to make a start. So if you can pop at the top of wherever you're making your notes, whether it be a Word document or a piece of paper or a notebook, we're going to just put linear equations or solving linear equations at the top of the page and put today's date, which is the 1st of June. But obviously, if you're watching a recording of this, you might put the date that you're currently watching this on, just so you can keep track of when you've done what. Okay, so essentially what linear equations are any equations where we have a letter that is a variable. So with an equation with a linear equation, there is one variable, letter, that you want to solve, and it's linear because there aren't any powers involved, so that letter is just as it is. It's not squared, it's not cubed, it's not to the power of 4, etc. Okay. If you have more than one variable, that's where simultaneous equations come in, which we will be looking at in some future lessons coming up. But before we go into, so for example, I'm just going to write down an example of a linear equation. So let's say I have 3a plus 4 equals 10. Okay, we'll get to solving that in a minute. But what we are looking to do today is to find that letter A. So we want to be able to identify, and it could be X, it could be Y, it could be any letter in the alphabet, any symbol even. But we want to find out what that unknown amount is. So in order to sort of understand the theory behind this, we're going to start by looking at something called function machines, which I'm assuming most of you will have looked at earlier in your schooling. It's normally something that is addressed in primary school, just the concept of function machines. And all it means is that with a function machine, you have an input that goes to a function that goes to an output. So if my function, I'll just put that there, if my function happens to be multiplied by 5, then let's say that I have an input of 7, my output is going to be 35 because I've input 7 into the function machine, the function has happened to it, and then my output is 35. Okay, let's say I didn't know the input. So let's say the input, we'll call it A. We know that whatever A was, it has been multiplied by 5 to make 45. Okay, so we know the output is 45, so that we know that we had a number, we multiplied it by 5, and it became 45. So in order to work out what that original number was, we have to reverse the function machine. So what that means is we go from the other direction, call 45 the input, but we've got to go backwards. but we've actually also got to reverse the function. So we need to think about opposite functions and operations. So when we're talking about multiplication, the opposite is always a division. And when we're talking about addition, the opposite is always a subtraction. So those two pairs are always opposite each other. So the opposite of multiplying by 5 is going to be dividing by 5. So if I put a division symbol there, so 45 divided by 5 is 9. So we know that the input would have been 9. So A equals 9. So you reverse the input. If we had a function machine where our functions were more than 1, so let's say, for example, I had 8 as my input, and my function was multiply by 2 first, and then I added 3. Okay, I got to think about what my output would be. So I multiply it by 2, and then I add 3. So that would give me 19. Okay. So let's say that I don't know that input, then I've got the same function machine, so everything's being multiplied by 2, and I'm adding 3, and my output happens to be 21. Okay, now what I have to do is reverse the function machine. So I go backwards here from 21. So the first function I come across is plus 3. Now, because I'm reversing it, I have to do the opposite function. So because it is addition, the opposite function is negative. So instead of plus 3, I'm going to take away 3. So I do 21, take away 3, which brings me to 18. I then continue going backwards along the function machine, and I come across multiplied by 2. So I do the opposite function to that, which is to divide by 2. So I'm at 18 at this point. I divide by 2, and I come up again with 9. So A equals 9 here. Okay, so why is this helpful? Let's look back at our initial equation. We're going to imagine that these linear equations are function machines. So the letter inside your equation is the input. Okay, so I might just write that there. Imagine that the variable in your equation is the input. So because it's sat next to 3, we know this from a previous lesson, anything's next to each other in algebra, it means multiplied by. So the input has been put in, and it's first been multiplied by 3, and then we've added 4. Okay, so you need to think about the order of this. So we need to reverse the order. So the most recent thing we did with this number, for the output to be 10, so this answer is the output, is that we added 4. So therefore, if we're going backwards, the first thing we have to do is take away 4. So 10 take away 4 is 6. We then continue reversing the function. So the first thing that happened to it was that it was multiplied by 3. We're at 6. We're now doing a divide by 3 because we're doing the opposite. So 6 divided by 3 is 2. Okay. So A would be 2. And we'll come back to those in a minute, and I'll show you how to kind of keep track of that and another way to think about it. But I'm just going to give you a few function machines to work through with outputs, and I want you to go back. So we're going to have input of A. Let's say that this time we added 4 first. Oh. And then we divided by 3. And our output was 3. Okay. We'll do another one. So let's say this time we multiplied by 6, and then we divided by 8. Nope, we divided by 2, and our output is 24. I'll do one more. So let's say we multiplied by 3, and then we added 8, and our output was 20. So what I would like you to do is look at those 3 function machines, and I want you to reverse them in order to find A, so to find the original input for me. So I'm just going to give you a few moments there. I'll quickly go over those answers then, and we can move on to actually looking at some equations. Okay, right, so let's have a quick look at those. Okay, so what I might do actually is just grab my pen, track this as we go. So my output's 3. I look to my most recent function, and it was dividing by 3, so I need to reverse that, so I need to multiply by 3. So 3 multiplied by 3 is 9, so that's where we're at there. I then look at my next function, which was adding 4. The opposite of that is minus 4, so 9 minus 4 is 5, so A equals 5. Similarly, let's make some room here. Most recent thing was divide by 2, so I will multiply by 2. So 48 times 2 is, 24 times 2 is 48. And then I would divide by 6 because I'm doing the opposite of that. So 48 divided by 6 is 8. So that means A equals, A? Yeah. A equals 8. Okay, so my output was 20. First thing I did was add 8, so I'm going to take 8 away. So 20 take away 8 is 12. And then the next thing was timesing by 3, so the opposite of that is divide by 3. So my answer is 4, so A equals 4. Okay, so let's just look up here. It's the same principle for this one. In fact, I'll give you some new ones to have a look at. So now we're going to kind of use that to work through some linear equations. So let's just say I have 4a equals 12. Now it's a very simple equation. We know this all that's happened to our input is that it's been multiplied by 4 because it's 4a. And this is our output. Okay. So the only thing we need to do is reverse this multiplying by 4, which means we have to divide by 4. Now, so the way I like to track each step that I'm doing is I put square brackets next to each step of the equation, and I write the function that I'm doing in order to get to the next step. And essentially what you're then doing is this function to each side of the equation. Another way of thinking about linear equations, or any equations in fact, is that because this is an equal sign, it's like a pair of scales that you want to continually balance. So you never want one to be heavier than the other, which means that you always have to do the same thing to each side to keep them equal. So if I divide 4a by 4, I end up with just a, and if I divide 12 by 4, I end up with 3. So A equals 3. Okay, so I'm just going to give you 1 minute now. I'm going to give you 3 other questions very similar to that. And I would just like you to write down what the answer would be for each of these. So what A would equal. So we've got 5A equals 50, 12A equals 36, and 7A equals 49. Okay, so just 1 minute. Just telling me what A is there using this concept up here. Okay, lovely. So for this one, I would need to divide by 5. So A equals 10. For this one, I divide by 12. So A equals 3. For this one, I divide by 7. So A equals 7. Okay, so it works the same way with division. So let's say this is presented to me as A divided by 8 equals 9. Okay, now I'm using divided by with a fraction line because that's how it's nearly always presented in algebra. Okay, so using that fraction line to mean divided by. Now, what that means is I've put in an input and I've divided it by 8 and my output is 9. So in order to reverse this, I go from my output, I look, the first thing that happened, or the only thing that happened, is divided by 8, so I reverse it. I've got to multiply it by 8, so I go multiply by 8, so A equals 72, okay? Because when you multiply this side by 8, it cancels it out, okay? So A divided by 8 multiplied by 8 is just A. Now this is the case with any fraction in an equation. So let's say, just for argument's sake, I had x over a plus b equals c. To get a plus b on the other side, because it's being divided by over there, I have to multiply everything by a plus b as a whole in brackets, so it would disappear on the left and it would turn up on the right, something like that. Okay, so that's just something to be aware of. If you'd like to move the denominator of a fraction from one side of the equation to the other, you always multiply it. But it's because you are reversing that function that we did earlier. Okay, so similarly then, so let's say I had a over 5 equals 75. That's an interesting one. Didn't quite mean to do that, but I'll let you have a go anyway. A over 2 equals 16. And finally, a over 8 equals 3. Okay, so just a minute now again on your own. I'd just like you to work out what a is in those 3 cases. Okay, so let's have a quick look. So in this case, to reverse that dividing by 5, I'm going to have to multiply it by 5. So I'll quickly do a column addition for that. 75 times 5. 5 times 5 is 25. 5 times 7 is 35. Add the 2. 375. So A equals 375. Here I'm going to have to multiply by 2. So 16 times 2 is 32. So A equals 32. And here I'm going to have to multiply by 8. So A equals 24. Okay, lovely. Right, so if we have a look at what would happen if we had some addition. So if I had A plus 5 equals 8, again, this is our output, and this is our input. So all that's happened to our input is that we've added 5. So therefore, the reverse of that is going to be -5. Take away 5. So I'm going to -5 from both sides. So that 5 will disappear. So it's going to be a, and then 8 minus 5 is 3, so a equals 3. This works exactly the same with subtraction, so a minus 4 equals 7. So in order to reverse that function for the input, I have to add 4. So always the reverse of what's going on. So a equals 11. Okay, very quickly then, I'd just like you to do a couple of those. So a plus 3 equals 12, a minus 8 equals 19. Okay, so just let me know what a is there, just 30 seconds, and then we will look at combining different functions and operations. Okay, so because we added 3 here, we'll have to reverse it. We take 3 away, so a equals 9, and we'll have to reverse taking away 8, so we're going to add 8, so a equals 27. Okay, lovely. Right, now putting those together, I'll just get rid of some of this stuff. It's not actually letting me do that, is it? Just move it down. Okay, right, so let's say we have 5a plus 2 equals 37. So we know that our input has been multiplied by 5 and then 2 has been added. So we know that we're going to have to reverse that by dividing by 5 and taking away 2. But what's really important here is to take notice of the order that those things have happened. Because when you reverse a function, if we think about our function machines, you always have to reverse the function that's happened most recently first. So if you look at the position of our letter there, it's first been multiplied by 5. So our input is being multiplied by 5 and then we've added 2. So the most recent thing that's happened is that 2 that's been added, which means that's the first thing that needs to change and needs to move. So we'll reverse that -2. So what that means is we're basically taking away 2 from both sides. So that 2 will disappear. We're left with just 5a, and then we have 37 take away 2, which is 35. And now we've just got 5a equals 35, and we know the last thing is to divide by 5 to reverse that function there. So we have a equals 7. Okay. So what I'm going to do is run through a few examples of different types, and then I'm going to give you some to work through. So of course we could also have division. So let's say we have a plus 7 equals, divided by 4 equals 3. Now, if we look at the order that these operations have happened, our input is here. The first thing that's happened is we've added 7, because a adds 7 together is actually being divided by 4. We haven't divided it by 4 first, okay? So it would be different if it was this, if it was a over 4 plus 7. That's different because the most recent thing that's happened is the adding 7. But in this case, because we've divided everything by 4, the most recent thing is the division by 4, which means that we have to multiply by 4 and reverse that first. So we end up with a plus 7, because that will then disappear, equals 12. And then we take away that 7 to finish. So a equals 5. Okay, so just another example is when you might have brackets involved. So if you want to go back to our video on simplifying algebraic expressions, we went over factorizing and expanding brackets. But let's say I had 2a plus 3 equals 20. Okay, Now, technically, the most recent thing that's happened to that a is it's been multiplied by 2, so we could divide it by 2 first, because it's gone a plus 3 and then everything's been times by 2, so we could divide it by 2 first. I do find, though, that it's easier to keep track of these equations if you multiply the brackets first, because sometimes that can get a bit confusing. So if we multiply it out, we end up with 2a plus 6 equals 20. So now the most recent thing that's happened is that plus 6. So we take 6 away, so we end up with 2a equals 14. And then we divide by that 2. So a equals 7. Okay. Right, so I'm just going to give you about 5 questions now, just to consolidate some of that. If you feel that... Okay, so apologies. I think it stopped recording briefly. So we're back now. So everybody on YouTube, please have a go at finishing those off, and then for those on Patreon, we are going to continue to a longer worksheet. So yes, off you go, a few minutes, and then we will carry on. Sorry about the pause for those of you watching live. Okay, so let's go over these. Right, so 3a plus 8 equals 35, so I'm going to take away that 8 first. So I end up with 3a equals 27. I'm then going to divide by 3, so a equals 9. I'm going to expand these brackets first. So 4a minus 8 equals 32. Add the 8, so 4a equals 40. Divide by 4, so a equals 10. Okay, so I'm going to multiply by that 9 first. So multiply by 9. So a plus 7 equals 18. And then I'm going to take away 7. So a equals 11. Okay, so the most recent thing that's happened here is actually the add 2. So I'm going to take away 2. So I end up with a over 9 equals 7. And then I'm going to do multiplied by 9. So a equals 63. Okay, here, so I'm going to add that 4. So I end up with 5a equals 55. And then I'm going to divide by 5. So a equals 11. Okay, lovely. Right, so thank you very much, everybody on YouTube. Please remember to like, comment and subscribe, and consider joining the Patreon, where you will be able to watch all of these full videos with the worksheets that you can download yourself and work through. And the worksheets are really there to make it a little bit more engaging, but also to consolidate the learning, because it's really important that you have the time to practice and allow those pieces of knowledge to sink in a practical way as well. Well, thank you very much for joining. Please join us next time for another GCSE English lesson, and I will see you then.